A warm greetings to all. In this video, we will discuss about inference in Bayesian network. Inference in the sense how to the network we will be asking the question and then how the model will be providing the answer. So that's what we are going to discuss here. So this is an probabilistic inference system which is used for calculating the posterior probability. We know like in all the methods we will be calculating the posterior probability. So here since this is an inference only with the question we can start with. So here we are going to find the probability of the burglary is given as John is calling and then Mary has called. So this is the question. So already we have computed all these things in the lab itself. The same answer here also you have to get. So that we will be verifying here. So in the inference there are two types. One is a inference by enumeration and then inference by variable elimination. So coming to the first method, inference by enumeration. So this is an algorithm here which is being used for identifying that is calculating the posterior probability. So here the only thing what we have to understand is like we will be enumerating all the hidden variables. Enumerating the hidden variables in the sense all possible combinations for the hidden variables will be considered over here. So this is the typical example what we are going to consider. So burglary, earthquake, alarm, and then John calls and then Mary calls. So the question is like here you want to identify the probability of the burglary. Yes, given as like John is calling and then Mary is calling. So here you are going to identify the probability of the burglary in the sense burglary happened we will be calculating and then burglary not happened, both the things we will be calculating. So here this is the general formula, standard formula that we will follow for enumeration. Probability of x given E. X in the sense it is the question what we are giving. E is the evidence variable. So this is equal to alpha of probability of x comma E. Alpha in the sense it is nothing but a constant. So to make this probability as 1 we will be using this alpha. So here again this will be expanded as summation of y in the sense the hidden variable here. So x is a query, E is a evidence and then y is the hidden variable. To this example what is the hidden variable here means burglary is a given, you have to find and then John calls and Mary calls are the evidence. The hidden variables will be alarm and then earthquake. So for both this hidden variables we will be calculating true and then false. So this is what will be done in this enumeration. So the hidden variable for this query are earthquake and alarm. So based upon the question you will be identifying the hidden variable. So here burglary, John calls and then Mary calls are the given things and then what you are going to find. The left out things are earthquake and alarm. So these both will be considered as a hidden variable. So this is the general formula. So probability of B in the sense burglary and then given John calls, that is for J and then M. This is equal to alpha of probability of B comma J and then M. So this is equal to alpha summation and then E and then summation A. E is for the first evidence variable, that is earthquake, and then A is for alarm. So this is equal to probability of B comma J comma M and then E and then A. And then here so this is the general formula what we are going to calculate. So this can be expanded as so summation of E and then A and then probability of B, probability of E and then probability of A given B and then E. So probability of B is the parent and then probability of E is also the parent and then probability of A is alarm, so which is dependent on B and then E, and then next is probability of J, John calls given as alarm, and then probability of Mary calls given as alarm. For John and then Mary the parent is alarm, so that's what it has been written like this. And then here if you do, so for all the four terms you have to calculate. That is like first is like alarm true and then alarm false, you will be trying it. And then similarly for E you will be calculating using true and then false. So this is being done over here. So this is equal to probability of B into probability of E is equal to true, and then probability of A is equal to true. So the same formula which is being said before is used over here. And then here A alarm is taking the value true in all the case, and then E is taking up the value true. So this is the first case. You substitute all the values and then you get this probability. And then term 2, so here where A value here you will change it as false. So and then this will be considered as the second term. And then E is equal to true, A equal to true. This is the first term. Second term is E is equal to true, A is equal to false. And then the third term is E equal to false and then A equal to true. And then the fourth term is E equal to false and then A equal to false. Yes, with all these things you will be calculating the probability. So use this previous probability, the diagram over here, and then use the values so that you will be getting all these four terms. And then here we sum all the terms, because here in the general formula it is given like summation. So all the four values I add it up, and then so this is the value that we got for burglary equal to true. So here probability of B, in the sense B value we have assumed as true, and then we have calculated this probability. Similarly for burglary equal to false, you have to substitute all the things and then you have to calculate. Yes, when you are calculating for burglary equal to false, you will be getting all these four terms. So first the probability of burglary equal to false, and then E value and then A value you will be changing. Why? In the sense those were hidden variables. So all those four values you will be adding. So that values will yield up to 0.0014919. So both these probabilities were unnormalized probability. To convert this to normalized probability, and we use this formula. So that is equal to, for example, to convert this to normalized form, the formula used will be 0. The one term you will be taking up and then divided by the total term. Xi divided by summation of xi will give you the normalized value. So the normalized value for burglary equal to true is being calculated. Similarly for burglary equal to false, this is being calculated. So it says like the chance of burglary happening is 28%, and then the chance of burglary not happening was 71%. So this is what is being done in enumeration method. Coming to the next method, inference by variable elimination. So the same example is being considered. So here also you will be identifying the probability of burglary given John calls and then Mary calls. So the same formula. So I started from the parent. So these two were parent, and then A depends on the parent. So for A the evidence will be the parent, and then for John the evidence will be the parent, that is alarm. For Mary the evidence will be the alarm. So here what you do is, in the previous method enumeration, the same calculation is being done repeatedly. So that was the drawback identified in enumeration. To remove that drawback, this variable elimination came into existence here. So here what is being done means summation A and then summation E is being separated. So here alpha probability of B doesn't depend on E and A. So you bring this outside. And then inside this first summation you have probability of E. The variable that is holding this E alone will be here, and then summation of A, just you are expanding this and then you write it. You rewrite the previous expression in this manner. Summation of A and then summation of J given A, and then probability of M given A. So all this three things is being written because these variables dependent on this A, that is alarm will be taking two values, that is A and then B. So here in this variable elimination, we will be using the factors. What is the use of factors means? It is used for storing the intermediate values so that you can reuse it again and again. Probability of B can be rewritten as F1 of B, and then probability of E can be written as F2 of E. So this can be written as F3 of A comma B comma E. Probability of J given A can be written as F4 of A. Probability of M given A can be written as F5 of A. So the same thing I'm using here, alpha instead of probability of B, F1 of B, summation instead of probability of B, F2 of E, and all other things I write it here. And then so I substitute all the values, F1 of B, so that is a probability, burglary will be taking both the values, true and then false here. So I'm going to find the value for burglary true and then burglary false. So in case if burglary equal to true, the value was 0.001. So from the question I have taken up this values, probably equal to burglary equal to false. So that is what 0.99999. And then F2 of E. So E in the sense earthquake true. This is the value, and then earthquake if it is false, so this is the value, and then I'm calculating F3 of A comma B comma E. So A will be taking up true for the first time, and then because here alarm is being considered as a evidence variable, so alarm initially will be taking true. So A value will be true, and then B and then E. So both combinations will be there, true, 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 false, false, true, false, false. So that will be giving up all these four probabilities, and then F4 of A you calculated. So John calls, in the question itself it is given like John is calling, so true value alone we will be taking. So for A, first initially alarm A equal to true we have considered, and then A equal to false we have calculated, and then this is the probability. Similarly Fi of A we have calculated, and then M is equal to true because Mary calls is equal to true, and then alarm equal to true, and then false we have calculated. And then so this is the general formula, and then for our burglary equal to true, so this is the probability we have calculated, and then burglary equal to false, this is the probability we got it. So here we substitute all the values. For alarm A equal to true, you will be calculating this. For alarm false, you will be calculating this. You will be summing up both the things. Similarly for E also, true and false you will be substituting, and then you will be getting these two values. And then at last we will be calculating the normalized value. So the normalized values you know the formula, so you will add up both the things, and then so 0.00059224 divided by this will give you, divided by the total will give you the 0.284. Similarly for burglary equal to false, the probability calculated was 0.716. So from this it has been understood like the burglary's probability was higher, and then this doesn't happen